G'day and welcome back to the Fixing Blender series, the series aimed at improving Blender. So first of all, I just want to say the feedback from part one was absolutely tremendous. I've seen thousands of comments all across Blender Artist, on YouTube, Twitter. Seems to be lots of people discussing Blender's interface at the moment, which is just fantastic. Everybody's being very respectful in sharing ideas, and I think that's wonderful. So in part one, we went over the first four of the usability guidelines, and in this part, we're going to cover the remaining four. So again, I just like to remind everyone that this series is not to poke fingers at anyone, especially not those people that were involved in developing Blender. This really is just to open the dialogue, get people discussing and thinking about new ways that we could improve Blender's interface, because I really do believe that it is one of the most important things, and it's going to affect pretty much everything. The amount of users that join Blender in the future, the amount of future jobs that are going to be available for Blender. So I think it's very, very important. So with that in mind, let's go ahead and get started on part two. Starting with number 5, feedback. Over the past 4 decades, researchers have found consistently that an interactive system's responsiveness is the most important factor in determining user satisfaction. That's right, feedback is the number one influence for user satisfaction. So what is it? Well, feedback is simply informing the user that their actions were received and that the software is now busy performing the task, which sounds pretty easy. But there's actually quite a lot of psychological rules to adhere to. And it's psychological because the human mind is wired to see cause and effect. For example, if I were to kick this ball, I expect to see the ball move. Cause and effect. Now, if the ball doesn't move within 0.1 seconds, then I'll have difficulty believing that I kicked it, and so I might try to kick it again. Now, obviously, this makes sense in the real world. But in the computer world, it's all too common to click a button and not see a response for a really long time. Systems that display poor responsiveness do not meet human time deadlines. They don't keep up with users. These problems impede users' productivity and frustrate and annoy them. In a nutshell, here are the response times that software must adhere to. When a button is clicked, it must display a response within 0.1 seconds. When an object is moved or resized, it can't lag behind the cursor for more than 0.1 seconds. If the software is busy for more than 1 second, it must display a busy indicator. And for any action taking longer than a few seconds, a progress bar must be displayed. So first, let's talk about the button clicking. If software waits longer than 0.1 seconds to show a response to a user's action, users will assume they missed and try again. Now, Blender gets this right in some places, but in other places, the button presses aren't always acknowledged, like with the modifier stacker. It leaves the user wondering for a very long time if their command was accepted or not. Next is moving and resizing. If an object the user is dragging or resizing lags more than 0.1 seconds behind the user's pointer movements, users will have trouble placing or resizing the object as desired. Again, Blender struggles here as it tries to move a high poly mesh. Now, obviously the cause of this problem is the high poly mesh, and we can't seriously expect Blender to bend the laws of computing physics to display complex meshes at faster rates. However, there are ways around these technical limitations, such as reducing the complexity of what's on screen whilst an action is being performed. When your system cannot update its display fast enough to meet this hand-eye coordination deadline, provide lightweight simulated feedback until the goal is clear and then apply the real operation. Windows demonstrates this well when it's resizing its windows. On fast computers, it resizes them with the content still displayed. But on slower machines, it shows only the outline of the window as it's being resized. It does this because frame rate and precision is more important than pretty visuals. Blender could tackle this issue in a similar way, by automatically switching the mesh to a boundary box or a lower res subsurf whilst the action is in motion. Then once the action is finished, the normal visuals can resume. Next, the busy indicator. Software should display a busy indicator for any function that blocks further user action whilst it is executing, even if the function normally executes quickly. Blender is pretty good with it in places, but there are some areas where Blender is occupied with an action of upwards of 10 seconds, and there is no busy indicator. It may not seem like a big deal, but without the acknowledgement that Blender is working on something, the user may wonder if it's just frozen altogether. The solution is to display a busy hourglass figure for any task that may take even slightly longer than 1 second. Next is the progress indicator. Progress indicators should be displayed for any operation that will take longer than a few seconds. They greatly increase the perceived responsiveness of an application. We're most familiar with progress bars when copying files. It tells us how many files have been copied, how many to go, and how long it will probably take. This is valuable data as it lets the user know if they're free to step away from their computer, make a coffee, and come back later. But without a progress bar and an estimated wait time, users become irritable and frustrated for not being told how long they should wait. Blender does something similar when it's baking by changing the cursor to a percentage, but a better option would be to display a dialog box with a cancel button, letting the user know that no other action can be performed, as well as displaying an estimation for how long it's likely to take. Provide some indication for how long operations will take. Free the user to do other things while waiting. And then there's rendering. Whilst it shows a progress bar in the top right corner, it again misses the mark by not showing an estimated completion time. This information is crucial, especially for animations, where knowing the completion time is highly important. Currently, users are forced to do their own sloppy calculations with a calculator, when it could easily be displayed within Blender. Poor responsiveness. Time-consuming operations that block other activity and cannot be aborted, and providing no clue for how long lengthy operations will take. It could even be taken a step further by showing each step of the rendering process before rendering begins. This would actually kill 3 birds with 1 stone, as it will let users know what's done and what's to do, give them a chance to step away and do other things, as well as in the event of an error, let the user know which step it failed at. And lastly, it should be noted that these time constraints aren't really optional. They really need to be adhered to pretty much by the book. Those deadlines are psychological time constraints wired into us. They are not arbitrary targets that we can adjust at will to match the limitations of the web or of any technology platform. If an interactive system does not meet those deadlines, users will consider its responsiveness to be poor. So in summary, the more feedback and more response Blender provides, the happier its user base becomes, and the more likely users will stick with Blender. Number 6, recovery from mistakes. Help users recognize, diagnose, and recover from errors. The most basic example is, of course, Ctrl-Z, universally understood as the way to undo any action. Now you may not know it, but this simple function that was first introduced in 1976 has made every computer user more relaxed, more explorative, and more trusting of the software they use. The reason for this is that people who are anxious and afraid of making mistakes will tend to stick to familiar, safe paths and functions. When exploration is discouraged and anxiety is high, learning is severely hampered. It's so important that you now find it in non-software related tasks, like using the elevator. Once upon a time, pressing the wrong floor button was a doozy, making everybody on the elevator groan. But nowadays, a lot of new elevators allow you to cancel the floor by simply repressing the button. It's simple, but it's powerful, as users can now approach the button panel with more recklessness, as the fear of pressing the wrong floor has been eliminated. In Blender, undo is fairly well implemented. Almost every action is immediately reversible with a quick Ctrl-Z, which is great. However, there's one strange behavior about the undo function that most Blender users have to learn the hard way. Undo doesn't just reverse the last action, it reverses the last action of that object's mode. For example, if I'm in edit mode and I make a bunch of changes to the mesh, then I exit edit mode and press undo, it doesn't just reverse the last action, it reverses all edits made in that object's state. And whilst it's true that you can redo it, if you accidentally click anything else between that time, you've ruined that chance. The undo is now permanent. This leads to that heart-stopping moment where you realize you've just undone about 15 minutes worth of editing and there's no way to go back. People need to feel they can try things without damaging the system or jeopardizing their data. So whilst the undo function generally reduces anxiety, in Blender it's also unintentionally causing anxiety by the way it's implemented, as users need to think carefully about how many times they press it for fear of accidentally undoing all their work. A fix for this would be to make the undo function work chronologically, regardless of the object's state. Adding this functionality would allow users to be much more reckless with the function, as the fear of losing work would be eliminated. Then there's the issue with crashing. Now, crashing is an inevitable part of software. It happens across the board. But the way the software recovers your last project is very important. In Microsoft Word, if it unexpectedly closes, it will ask you on reopening if you'd like to review the last autosave. Blender has autosave functionality too. However, most users probably aren't aware of how to use it. Blender keeps an autosave of open projects with quit.blend. It also regularly saves every 5 minutes to a .blend1 or .blend2 file. But this functionality is rather unique, and so most users aren't aware of how it all works. In fact, it took me years before I realized this was happening in the background. The file menu provides some sort of solution to a crash with the options Recover Last Session or Recover Last Autosave. However, both options seem equally as likely from the user's point of view. A better solution would be to simply leave it to Blender. After crashing, Blender could prompt the user if they'd like to recover the last file. This removes the stress from the user and leaves it entirely up to Blender to recall whatever file is the latest, adding some much needed juice to that old trustometer. Number 7. Simplicity. Finally, the part where we get to discuss the software's appearance. Simplicity is all about making the interface as easy to understand as possible. And ironically, simplicity is the biggest category. It can be broken down into the following 4 subcategories: hierarchy, structure, design, and vocabulary. First, let's talk about hierarchy. Hierarchy is about the order of buttons and the functionality that is on display, with this basic principle in mind. The larger the number of people who will use a function, the more visible the function should be. Hierarchy is extremely important as it directly affects how fast users can work, as unnecessary digging for buttons can slow users drastically. Make functions that many people need highly visible. By contrast, functionality that few people will use, especially when those few people are highly trained, can be hidden. Example, behind details panels, in right-click menus, or via special key combinations. To see this principle in practice, you only need to sit in the driver's seat of a car. Everything you need for the purpose of driving is easily accessible. The steering wheel, the accelerator, the brake, and the gears. Each placed in a comfortable position from the driver and sized appropriately. Now, of course, there are other functions required for driving as well, like the headlights, indicators, opening the gas flap, mirror control, seat adjustment, but these obviously aren't as important as the first 4, and as such, they aren't as big or as accessible. For example, imagine if a car manufacturer put a huge button right in the center of the steering wheel just for releasing the gas lid. That'd be pretty stupid, right? Because even though releasing the gas lid is a needed function, it's only used maybe once a week, so placing it in a prominent position would be silly. The same measuring stick should be held to software. For example, for Blender, unfortunately the button hierarchy is a little random at the moment. Going by size alone, the largest button in the render panel is the render presets drop-down box, which I personally have never actually used. And I'm sure it does have its place, but it's perhaps not as important as, say, the cycle samples, which are currently buried 4 layers deep in the sampling panel. Minimize the number and complexity of settings. Don't expect people to optimize combinations of many interacting settings or parameters. People are really bad at that. Now, I should take a moment to explain that developers should really be given a break on this one, as they've been continuously encouraged by the community to add more and more and more functionality to Blender. And so the number of buttons has obviously grown larger and larger. It's one of the carryover effects of good development. But Blender has now reached a stage where a reassessment of its functions is in order. Something like a priority system tagged to each button and then reordered to reflect that. Also, there's something called Fitts Law. This rather sophisticated mathematical equation predicts that the time required to rapidly move to a target area is a function of the distance to the target and the size of the target. Basically, a button like this takes a lot longer to click than one like this. So again, going by the rule of hierarchy, some buttons and functions should be bigger than others, much bigger. Blender could use a radical button reassessment to put the most used functions in an easy to reach place to the user. The next topic on simplicity is structure. This relates to how buttons are presented, or more specifically, how they're presented in relation to each other. Now, way back in the early 20th century, a group of German psychologists discovered that the human mind is wired to see structure in shapes, figures, and objects. They named their discovery the Gestalt principles. The most important Gestalt principles are proximity, similarity, continuity, closure, symmetry, figure ground, and common fate. But in Blender's case, I'm going to focus on the two that are most important: proximity and similarity. For example, it's likely that you'd see this not just as a group of arbitrary dots, but as two separate groups of dots. That's the principle of proximity at work. Objects that are near each other, relative to other objects, appear grouped, whilst those that are farther apart do not. This is a common method in software interfaces for letting users know which buttons are related to others. Google Documents puts bold, italic, underline, and color buttons next to each other, signifying to the user that they perform similar tasks, in this case, text formatting. In Blender, you can see that these values are joined, so you'd be right in assuming that they are related. However, there are some parts of Blender where it confuses users by joining values that aren't actually related, like the seed and clamp value. Users may be fooled into thinking that one value will affect the other, when in fact they are independent of each other. For the most part though, Blender gets this right, but there are a few areas, particularly relating to the Cycles rendering system, which have been overlooked. Next is the Gestalt principle of similarity. Like this bunch of dots, you would probably notice that the hollow circles in the middle are similar, and therefore you would assume they are different from the rest. Objects that look similar appear grouped, all other things being equal. This is used again in Google Documents with the text alignment functions. The buttons look very similar to each other, so we're able to guess that they perform similar functions. In Blender, there's a bit of a problem, as most buttons look identical to each other, so it's much harder to guess if there is any relation or difference. For example, the baking buttons in Blender look pretty much identical to any other button out there, yet they perform very time-consuming tasks. Then there are buttons that cause confusion by reusing icons, like these two buttons in the 3D viewport. They look very similar to the render and animation buttons, but actually they perform a completely different type of rendering known as OpenGL. In the output panel, the similarity and proximity of these choices may lead users to wonder if one value will affect the other. By separating them, changing the sizes, or in other ways making them appear different, the user will not assume this relation. So that's it for structure. By better adhering to the Gestalt principles of proximity and similarity, Blender can help users better understand the button's functionality. Next on the simplicity topic is design. This means making things clearly visible. Have you ever found yourself squinting to find the objects in your scene? That's because black outlines on dark gray backgrounds are hard to spot. Blender's background is a value of 0.224, and the wireframes are a solid black, meaning that we're only getting a contrast difference of 224. However, for good readability, a minimum of 430 is recommended. To put us in the good readability range, we'd need to brighten the wireframe to 0.660, making it a whitish grey color. Now it looks a little strange at first, but after a while you'll find it's a lot easier to see your scene without squinting. Plus, it also has the bonus effect of being more consistent with the solid view, which is also grey. Now, let's talk about text readability. Have you ever found that after using Blender for several hours on end that you're hunched over your monitor? Well, that may be because the default font size in Blender is 11 pixels. Now brace yourself, because this may come as a shock, but the recommended font size for computer viewing is 16 pixels. Which I'll agree, sounds ludicrous at first, but there's actually some solid reasoning behind it. The readability of text depends on the distance you are from the source. So whilst 12 pixels is a pretty standard size for a magazine or a book, you normally read those at a distance of about 35 centimeters from your face. But on a computer, most people sit comfortably from their screens about 60 centimeters away. And to read text that far, obviously 12 pixels doesn't cut it. So nowadays, many web designers recommend that 16 pixels for text on monitors is the standard. Initially, our claim that Georgia 16 pix was a good benchmark for body text sizes provoked a lot of anger and even some laughter, but now it's more or less a common standard. To test this font size out in Blender, go to the user preferences and set the system DPI to about 100. Now at first you'll probably laugh and want to change it back, but just try it out for one day. The new size irritates you in the beginning. Don't worry, that's normal. However, once you've gotten used to it, you will not want to go back to the standard small sizes. So that's design, improving the visibility of Blender. By doing so, we can make it easier for users to work and allow the users to relax while using it. And finally, the last topic on simplicity is vocabulary. Good vocabulary is simply avoiding jargon and saying less. Don't force your users to learn a whole new vocabulary. Familiar words are easier to read and understand because they can be recognized automatically. Jargon. A lot of software has it, but it's poison for usability. And Blender is fairly guilty of it too. A lot of settings, descriptions, and names are unfamiliar, and as such, you may have been avoiding them for years because of it. Take this translate button, for example. This word really doesn't make much sense from a user's perspective, as translate doesn't really mean anything other than translating a language. But in Blender, this button actually means move. By using a more familiar name, we can reduce the number of questions raised when users encounter it. Why did they name it that? The most important thing you can do is to just understand the basic principle of eliminating question marks. Along the same lines, normal is pretty confusing as well, as it really doesn't give any clues as to what it does, as is progressive, vorticity, delta transform, integrator, OpenGL, rotation, Euler, and clamp. Now I'm sure all these terms make a lot of sense in the tech world, but for users they don't. Although in some cases they may be the standard naming convention, they could still be simplified, and in doing so, more users would use their functionality. When readers, even skilled ones, encounter jargon, their automatic reading processes probably won't recognize it. Instead, their brain uses processes, such as sounding out the word's parts or looking up the word in a dictionary. There's also the case of acronyms, like with all the shaders ending with BSDF. Now, since this information serves little use to the user, it's probably more likely to scare them, and therefore it could be removed. Tell users explicitly and exactly what they need to know. Don't expect them to deduce information. Don't require them to figure things out by process of elimination. But the biggest vocabulary problem in Blender is probably in the tooltips. Now, tooltips are generally a user's best friend, as it helps them better understand the software's functionality. But in Blender, many of the tooltips are overly long and presented in more technical terms, serving just to confuse the user more. Many software user interfaces simply present too much text, requiring users to read more than is necessary.
Software designers often justify lengthy instructions by arguing, we need all that text to clearly explain to users what to do. However, instructions can often be shortened with no loss of clarity. The most confusing part of the tooltip lies in this part here at the bottom. This daunting purple text is called a Python tooltip, and it's designed to show developers where the appropriate code is in relation to the function, which I'm sure is a huge time saver for developers. However, the problem is that it's turned on by default for all users who download Blender. Just by being there, all the extra words suggest you may actually need to read them to understand what's going on, which often makes pages seem more daunting than they already are. To avoid scaring off new users, Python tooltips should really be left off by default, and doing so would give new users a cleaner, easier to read tooltip without scaring them away in the process. So that's it for simplicity: hierarchy, structure, design, and vocabulary. Which leads us to the final usability guideline. Goal-orientated. We focus on our goals and pay little attention to our tools. This principle is super important. In fact, if you were to only listen to one point in this web series, this is the one I recommend. The reason it's so important is that it's a complete paradigm shift to how we normally think people use software. We would assume that when people open a new piece of software, they carefully survey the software's functionality and play around with the settings until they get the hang of it. But this understanding is completely wrong. When people are doing a task, trying to accomplish a goal, most of their attention is focused on the goals and data related to that task. Normally, people devote very little attention to the tools they are using to perform a task. For example, say you had the idea of creating a yearly budget for your expenditure, a novel idea, and you opened Microsoft Excel to help you get the job done. You wouldn't be thinking in terms of cells, formatting, or columns. All you're thinking about is an answer to your problem, a budget outline. It's now up to the software to guide you to your goal. This tendency of people to notice only things on a computer display that match their goal, and the literal thinking that they exhibit when performing a task on a computer, has been called following the scent of information toward the goal. The scent, in this example, could be as simple as a screen of empty cells that lets you get what's on your mind onto the screen. Then the scent could lead you to menu options like formulas. Then before you know it, you've reached your goal. In fact, if the software is well designed, the user should be able to get in and out without even thinking about the software at all. Most software design guidelines state that software applications and most websites should not call attention to themselves. They should fade into the background and allow users to focus on their goals. Cognitive psychologists call the gap between what a user wants and the operations the tool provides the gulf of execution. To put it bluntly, users aren't thinking about Blender. They're thinking about their goal. And to reach that goal, they have to cross the gulf of execution, figuring out how to use Blender to reach their goal. If the software has a good interface, the gulf will be shallow and easy to cross. But if the software has a poor interface, then the gulf will be deep and hard to cross. Now you may be thinking, in terms of a large multi-purpose software like Blender, how is it even possible to create an interface that suits everyone? To do that, designers need to understand the goals that users are likely to have at each decision point in a task, and ensure that each choice point in the software provides options for every important user goal, and clearly indicates which option leads to which goal. The most important screen is the home screen, or what users see when they first open the software. From its first screen or home page, software should show users the way to their goals. And this is where we run into a very immediate problem. The home screen of Blender gives very little scent for reaching any sort of goal. This is mainly due to the lack of displayed tools or objects. Actually, the contents of the add menu would be perfect for the home screen, but it's currently hidden under a Shift-A shortcut. If we could somehow put the add menu in the interface and combine it with a toolbar, then we're giving people a lot of scent to reach their goals. Provide clear paths, including initial steps for the user goals that the software is intended to support. Next, we need some way of guiding the user to specific tasks, like compositing and materials, without them needing to know where it's buried in different menus. But how could we do that? Let me think.
To be completely honest with you, I do have a full interface proposal planned, but it's going to take a full video for me to explain all that to you. The reason being that although, everything else I've discussed in the series has been, a quick fix here and a, default change here, I think that the goal orientation aspect of usability is something that really requires a deeper understanding of what users do in Blender, their primary goals and the way they use the software, and then creating a layout and a hierarchy that suits those needs. So in 2 weeks' time, you're going to see a new video from me called The Proposal, in which I'll present my solutions to pretty much everything I've discussed in the last 2 videos. So again, just like last time, there is a survey underneath this video, which will ask you basically just the controversial questions. Things like, what font size do you want to see in Blender now? What color do you want the wireframe to be? What about Python tooltips? Just some of the more, controversial issues that generally get a lot of discussion on forums and things like that. And I think just getting a consolidated, data of just what everybody thinks as a whole will be very helpful. Because again, this will be, I think, largely based on votes. So when I approach the foundation with my proposal, I think that the results from these surveys will definitely have a large influence on that. So if you feel strongly about Blender's interface, please go ahead and fill out that survey. So that's all from me. You will see me again in 2 weeks' time with the proposal. Bye.